displacement electric field. We usually denote by D, that one. So what do you mean by what it is, like, So the basic definition is the charge per unit area that would be displaced across a layer when placed in an external field, external electric field. I'm telling you this one, at our level, we say, okay, E bar is important, but when you go for application, no, the D bar becomes very important. Displacement electric field. This is what is going to help us a lot in applications. That's why I just picked up a problem where you can see that the D bar is what will make problem very simple. We are learning only the basic fundamentals, not going for application part. In applications, rather than E bar, the D bar is what preferred, because usually in applications, what do you mean by application? In applications, what will happen is like how the behavior of material in an electric field, that becomes very important when we go for application. See, I do generate electric field. That electric field should have some influence on some material object, and how that material object will respond for that external field. That particular thing is what? Displacement electric field. So rather than electric field, the displacement electric field becomes very important. We don't discuss much numericals, only some small theoretical idea proposed in NCERT book. So, or it's a measure of response of material on the application of electric field. Means when you take a dielectric slab, when you keep inside between the plates of capacitor, there anything will happen to dielectric slab, charge is induced. No, again there are two types of insulators are there, polarized and unpolarized here. The one which is polarized, the dipole moments will get aligned, what we call linear dipole, that one. So, and what is the polarization vector? How you define the number of polarization vector? Only definitions we have. So it is defined by a symbol capital P bar, or PV, I'll write it, huh? So that, so it is defined as number of dipoles that are aligned by dipole moment, electric dipole moment, by volume, where what is V? V is called as N is number of dipoles aligned electric dipole moment. I think I'll write only EP, huh? Because we are familiar with symbol P, electric dipole moment, and V is volume of material. So to study the behavior of a material when it is placed in electric field, no, we have defined many things. This polarization vector, it is called as this one. If the material doesn't get polarized, so none of the dipole got aligned, N will become 0, then this polarization vector will become 0. Got this? So now this particular displacement, like a electric displacement field, or you can call vector this one, electric displacement electric field, or you can also call only displacement electric vector. This should be equal to epsilon into E, or this will become epsilon R into E. Our syllabus maximum, we confine ourselves to this. So if you look at the thing, even the polarization vector also will get added up, since we discuss all the numericals where epsilon r equal to 1. Can you remember? Uniformly charged sphere, non-conducting uniformly charged sphere. What was the value of epsilon r? We took 1. And we assume that none of the dipoles get aligned. Then we just took that as a charge q and we proceeded. The similar concept is what we are going to continue here. So we are not go in detail about the study of material. We are not bothered because we don't go for much application part. Only we are just involved in the study of basic electric field. So how the displacement electric field vector is related to electric field intensity. So this is what capital E is what? This you know absolute permittivity. This is called as relative permittivity. This is electric field intensity or strength, anything you can call it. So like this, what happened? This is what related. So any problems related to dielectric comes now, we should take help of displacement electric field. Of course, we took all the numericals where the with what we know with that somehow we managed it here. Okay, now look at the what actually displacement electric field here now. So you look at the sentence which I put rather than first one, no, this one is much easier for it's a measure of response of material on the application of what do you mean by response? How the charge in that will be induced. How that charge will be induced. The measure of that is what? The displacement electric field here. Now, what can be the dimensions of this charge per unit area only? Will agree this. So therefore, the definition there it is a charge per unit area that would be displayed across a layer when an external field when placed in an external field here. Means when you place a dielectric slab between the plates. So what happened to the dipoles? They'll get aligned, no? And because of that, what happened? A charge is produced at different points here. So what is the meaning of this? So let me. It's not there in none of our books except only in NCERT book. There's no much discussion in the basic books, competitive exam books, what we have. Only in NCERT book is there. Just me, only formula based he has given. So let's have that formula discussion. Then we'll take the application one problem. So when you place this dielectric slab, so a dipoles will be aligned, no? Here, what we had earlier discussion, minus plus. Now you just draw a line like this. So look at this layer. Some net charge is there, no? That one. So that net charge per unit, like that will happen. What we see that the charges will happen, a net charged layer is formed along the dielectric slab. Earlier what happened, what was the net charge? If you take the dielectric slab, which is not there in the electric field, then how the dipoles will be very randomly arranged. Dipoles position will be there only, but their orientation will be different here. So plus, minus, plus, minus, minus, plus. Now look at the net charge here, no? Will be 0. But when you place it, the same dielectric slab between the plates, so then what we see that the net charge, what happened, will be produced here. Again, net charge. So shall I say some sort of charge, net charge got displaced. I think this will be a little bit difficult for you, sir. I'm not saying the displacement of charge. The meaning of is telling. So here, what was the net charge? 0, 0, 0, 0, 0. Now, what you see, the moment you place it, no, the net charge will be produced here. You see the layers. A green color line I'm drawing. So where the charge will be negative. Next, I'll draw a yellow color line. So there you see that net charge will be positive. So some charge, shall I say, got displaced earlier 0, now negative. Earlier 0 got positive. So some charge got displaced here. So this particular, how that charge gets displaced, the measure of that is what? The you can say electric displacement. And what it should be equal to? What it should be equal? What is this E? This E is what produced by the plates, no? So that should be equal to total free charge. So one more definition for this, what they're telling is equal to ds bar is equal to q. What is the q here? Q is a free charge, because when you look at this expression, we'll end up this one. So like what is this circle? Integration in closed path, because ds I brought it, no? Or this twice we have to integrate, so let it be like this here. Already in Gauss you see, no, e bar dot ds. The similarly same thing here. Is it units matching? Check it. Yes, no, it should be. Both are same. Look at this equation and this equation. The interpretation is same, that one. So like this, we define displacement vector here. So now based on this, we'll take this particular problem. Advanced, I'm not sure, because it's there in NCERT book. So such it's there. I took problem from Pathfinder. Like if you fill up a dielectric slab like this, no, there's no other way. We have to go for displacement vector only. If you solve by any other method, maybe you just cooked it, maybe you manipulate it to bring the answer. But such numerical solvents should be solved by displacement method. So what is the dielectric constant here? Epsilon 1, then epsilon 2. Half of this one is filled up. So let the radius, let it be. So we have to find out the capacitance of this system. Okay, this is the, okay. Meanwhile, you try. I'll draw the diagram. Not possible. Two dielectric slabs are there. So one, I'll fill up. You try that one. Meanwhile, I'll finish off this shading part. Like this, there are. Yeah, diagram got over. So this is the radius A. So this is epsilon 1, epsilon 2. I'm going to connect again the cell where it will be connected. The cell will be connected between the inner and outer shell. So the method is same. So again, don't forget that the cell idea. The cell will be connected. This is the potential difference. If you can connect it anywhere. So I'm just put it this point. So here at point, is that so? If you want to make it very simple, you can connect it anywhere. So let this be the point P1. Let this be P2 or AB. You write it. Now how the electric field vector will be. This is like a boundary, no? Boundary between the slabs. So the electric field vector here will be like this, and in this region, and this is a boundary. So I'll define the displacement vector in both the regions. So this should be equal to d1 ds1 bar plus d2 ds2 bar is equal to the net charge. The net charge, or when the battery will supply charge, no, q minus q, and that plus q will flow like this. So the total charge supplied by the battery water pen, a part of charge will reside on here, and a part of that free charge water pen will reside here. So the total charge should be equal to again q, because this q will split up. What all the charge supplied by the battery should split up here. A part of charge will go like this, and the remaining part of charge will come here. Means a charge here will be plus q. The plus q will not reside here. It will get distributed on this, the surface of shell A. A part of charge will reside here, a part of charge will reside. That will induce a charge here, and it will induce a charge. So total again on outer surface charge will be induced. That the total will be Q only. So I'm just only to make problem very simple. I'm just showing Q and minus. Don't think that here no charge will be there. Here also some charge will be get deposited. Here also some charge will be get deposited. And what is the total charge? Should be equal to Q, what the battery supplied. So to make problem very simple, I'm just showing the flow of charge. The charge of a cell should be conserved. Okay, now, so what is electric displacement vector? So this should be equal to, and what is ds1 here? What's with the ds1? What is the meaning of that? So here, Orpan, you are going to assume an elemental surface here. So where we are defining this displacement vector, somewhere at this particular point, at a distance r. At a distance r, that one. So here this should be equal to epsilon, this will be into E into ds1. So this should be equal to epsilon2 E into ds2. So I assumed, because I think what is the surface area of, if I assume a shell, a thin shell of radius r and thickness dr. So what will be the surface of that shell in the yellow color region and blue color region will be same. So in fact, ds1 should be equal to ds2 equal to ds. So this should be epsilon naught E equal to integral of E1 plus the symbols epsilon 1, no? Integral of ds by q. So this is the, if you're getting confusion, write k1 k2. It's don't make again e1 e2. Huh? I'll do one thing. I'll replace. I'll change symbol so that will be easy for us, to me also. So integral of ds, that one. So integral of ds, what will get it? Should be equal to 2 pi r square. So what is the expression for electric field? Q by 2 pi epsilon naught k1 plus k2 r square. So this is the expression for the electric field. Next you can ask question like, say like, who will produce that electric field? So here what actually happens here? So here I think the symbol D1, I'll write it. Now, from where this, what is the, you can ask questions, sir, why you made E? These are the best questions what you ask. Instead of thinking some random, no, you ask very simple, go to electrostatics. What is the potential difference? These are conductors, no? Both are conductors. So what you calculate potential difference here at these, between these 2 points, the same potential difference should exist here also. And what is the potential difference? Equal to applied EMF V. And what is the separation between them? B minus A. So therefore, what do you expect electric field in both the regions must be same. Finished. There's no any other thought. Go back to basic electrostatics. What is the potential difference in the blue color region here? V. What is the separation? B minus A. What is the potential difference here? V. And what is separation? B minus A. So therefore, the field should be same. Then what? Because of different dielectric medium, the displacement electric field should be different. And what is the displacement electric field? This should be equal to the total charge that is supplied by the cell. So charge residing on this plus this supply. So I got the expression for electric field. So now once you know electric field, we know how to calculate the capacitance. dV equal to E into dr, then integrating, then we'll get the required capacitance. So that I'll proceed now. Since in NCERT book it is given for us, yes, discuss just only formula discuss. That's why I'm just going for this one. So VB minus VA equal to, this should be A to B Q by 2 pi r square dr.
How did you bring E out of
Wait,
the integration?
wait. In the end of the problem, you can ask, no? So this should be equal to VB minus VA is equal to Q by 2 pi epsilon naught K1 K2. So this is AB. Negative sign, so this will become VA minus VB. So this should be equal to minus 1 by R A to B. Here we'll write it. That everything should be equal to B minus A by 2 pi epsilon naught K1 K2 2 pi epsilon naught K1 K2 AB. So this should become 1 by C. CAB you write better. Between the points A and B we are finding out. So what is the capacitance given by here you are going to assume a strip at all points on that particular, you assume a strip here, no, or you assume a shell. At all points on that shell, the E will be constant. At all points on that particular thin shell, the value of E will be constant. So when I integrate that, it will be ds, no, what we studied in Gauss law.
Sir, area should be 4 pi r square.
Oh, no, I defined only for this region, no. Here, this one, for this.
Okay, sir.
I'm not sure, like, because none of our competitive books has asked anything questions of like this. Only in Pathfinder it